okay, is designing a bridge to cross a river. Now, she believes that the weight of the steel needed for building this bridge is approximately this amount. On the other hand, we have the exact weight of the steel needed for the bridge is this amount, okay? And so, of course, Saha is a little bit off. And because she's a little bit off, there is a, for part A, percentage error in Saha's approximation. So, just a quick disclaimer for this whole video, or what I suggest really, is that in order to face any exercise, you first need to identify buzzwords, keywords, key concepts. Okay, so whenever I talk about buzzwords, I'm talking about keywords, key concepts, important words, okay? Important words, important concepts. And so what you're going to do is that after you identify these, okay, this will be a big hint for the formula booklet, which will then be a big hint for the procedure. Now, some of the buzzwords and keywords and key concepts and etc. are not going to be in the formula booklet, and you're just going to jump straight to the procedure, okay? But for a lot of these, you guys, there is going to be a tool you can identify within the formula booklet. And so what I highly suggest is to get familiar with these, which allows you to get familiar with that, which allows you to get familiar with that. Okay, so this is just the sort of mentality that you want to embark upon when facing these exercises. And so the level that I need you to reach is at the moment that you read percentage error, you remember that it's somewhere in your formula booklet. You don't have to know it by memory, but you do have to identify it. It should ring a bell within your brain. So you read percentage error and you go ahead and open up the formula booklet and you say, I know you're in here and I'm going to find you. So you start looking for it and eventually you find percentage error. Will you look at that? How friendly. So our good old friend percentage error, how does it work? Yes, the formula looks kind of nasty, but let's go piece by piece. On the one hand, you have VA. Okay, so VA, as you can see here, is the approximate value. On the other hand, you have VE on the numerator and denominator, which is going to be the exact value. And last but not least, you have these two fancy looking sticks, which no, are not a parentheses, they're actually absolute value. So these are called absolute value. Why do you use absolute value? Why is it useful in the first place? The absolute value of 3 is 3. The absolute value of negative 3 is 3. Guys, what's happening here? Absolute value makes whatever is inside positive. Okay, whatever's inside now turns positive. So absolute value of negative x is going to be x. Absolute value of, I don't know, negative 7 is going to be 7. So all it really does is makes whatever's inside positive. So keep that in mind, you'll be fine. And the other small detail I missed is that you do multiply by 100% in order to go from decimal to percent. Okay, but I'll talk about that in a second. For now, don't worry about it. For now, you should really just focus that A, on the first place, this is a buzzword. And on the second place, it's in your formula booklet. So keep it in mind. ¿Vale? Let's go ahead and apply this formula. So on the one hand, you have the approximate value up here. So this is going to be your VA. And on the other hand, you have your exact value, which is right here. So this is going to be your exact. And if you follow the formula from the formula booklet, you can see that it's going to be, for part A, it's going to be absolute value of first the VA, so 53,632,000, minus the exact value, right? So the exact value is going to be 55,625,000 divided by the exact value again. Okay, so here I'm only following the formula from the formula booklet. There it is. See? And it multiplies by 100%. You'll see why in a second. See? So if you go ahead and open up your calculator, trusty rusty calculator, you can put a fraction just to make this more friendly. See? Like in theory, you could, do something like this. Or you can go ahead and put up a fraction using alpha, y equals, and these are all fractions. See? So you can put the first one, and here it's a lot more friendly, ¿cierto? It's a lot more friendly for plugging in, I mean. So from here, I'm going to go ahead and plug in everything I need, which is going to be the absolute value first, ¿cierto? So here goes the absolute value first. Make sure you put the right amount of zeros, double check, minus the exact value, which is right there. And here I divide by the exact value again, see? Now, two things happen here. On the first place, a decimal comes out, see? And on the second place, there's a negative value. And so if you want to be really rigorous in your approach, what just happened is that now you have the absolute value of negative 0.0358. And you still have a times 100% outside, see? And so what happens now is that the absolute value sort of applies, and this is now going to turn positive. Because as I told you, absolute value, all it does is that makes whatever's inside positive, right? 0.0358 times 100%. Also, I didn't mention earlier, but why do we want to make whatever's inside positive? It's because in the context of percentage error, you don't care about being like 10% above or 10% below. You only care about how off you are. So that's why we apply absolute value in this context. We just want to know by how much we're off. See, we don't care if we're above or below. We just want to know by how much we're off. So there we go. We put it as a positive value, and this is a decimal. See? But because we want to leave it as a percent, because we're talking about percentage error, whenever you want to go from decimal to percent, all you have to do is multiply by 100. And the other way is the same. If you want to go from a decimal, from a percent to a decimal, you actually divide by 100. So look at that. You just learned how to go from decimal to percent and from percent to decimal. So you take this decimal, you multiply it by, well, first of all, you make it positive. See? So times -1 will do the trick. And then we're going to multiply it by 100. So lo and behold, now it says a percent. The answer for part A is going to be 3.58. 3.58%. Okay, and just as a disclaimer, I should have mentioned it earlier, but I am leaving it in significant figures. My final answer, I mean the long version, is 3.58 2921. 292135. So you can leave it as this long sort of version, or you can get comfortable with significant figures. Count 1, 2, 3. Do you round it up or keep it the same? You keep it the same, so you can just leave it as 3.58%. Okay. The answer on the left is significant figures. The answer on the right is the long version. Either of them works. Do what you want. I left it like that. You can leave it like this. Nobody cares. Do whatever works for you. Okay? And notice you have a whole method point for using the percentage error formula. So this approach here, I highly suggest it because you're going to net all those method points, which show up a lot during the test. See, a lot of times the method points is really just identifying the right formula. And what has a bunch of formulas? The formula booklet. Okay, so that is the approach that I suggest. Do what you want. That's my suggestion. See? Anyways, enough blah blah. That is for part A. For part B, we have that SA has this design is used to build 5 identical bridges. And so for part BI, you need to find the weight of steel needed for these 5 bridges to 3 significant figures. Now, in order to be accurate, all we really need to do is use the exact weight for the steel needed for these bridges. So all you're really gonna have to do for part BI, which is fairly simple, is take the exact value, which is 55,625,000, and that is for one bridge. See? So that is for one bridge. For 5 bridges, you multiply by 5. Pretty straightforward. So you take this number, 55,625,000 times 5. That is the exact amount needed for 5 bridges. So your answer is going to be 27,8125. Whoops. 8125, and then a bunch of zeros, I think. And then a bunch of zeros. So that is your answer. See? Let me just double check because it looks a little weird. 27 8125 000 55625 000. Yeah, okay, looks good. The method is probably correct. So this is your answer for the amount of steel needed. See? But there's a disclaimer for part BI because the IB loves to put disclaimers. So the disclaimer here is that you need to answer to 3 significant figures. So unfortunately, this is something you have to learn, but hey, that's the point, learning in math. See? So let's get to it. How did you express significant figures here? What we're used to is expressing it with decimals, okay, which is much more friendly. It's what we're used to, etc. But in this case, you have a big number. So how do you express the decimal points? The significant figures for a big number. For a big number, the idea is still going to be the same. You read it from left to right. And so if you read it from left to right, you count 1, 2, 3, and ask yourself, do you round it up or keep it the same? Because it's a 1 next to it, you keep it the same. If it were 5 or above, you round it up. So from here, in significant figures, it actually ends up as 278,000, 000, or million, sorry, right? Kilograms. And so there is your answer in significant figures. All that's going to happen is that all these values ended up at 0. See? That's pretty much it. I can't explain it any more than that. It's just significant figures with big numbers. We check our answer here just so that we all feel comfortable. And there it is. See? So for part BI, really just be careful with significant figures. Get used to using it with big numbers. See? So you just go ahead, count 1, 2, 3, see if you round it up or keep it the same, and the rest of it is going to end up as a bunch of zeros. Lo and behold, that is part BI. For part B double I, we need to write down the answer from part BI in this form. And just in case, if you want to Google it, okay, this is scientific notation. And I know there's a bunch of stuff happening here, but on the one hand, let's go piece by piece. They ask for A to be between 1 and 10. This is pretty standard for scientific notation. And they also ask for K to pertain to the values, I can't find the word right now, but to the group of Z. And Z, you guys, is integers. What the heck are integers? Integers are whole numbers that are negative. So all your integers, okay, is going to be -3, -2, -1, 0, 1, 2, 3. Okay, those are the integers that you're going to be using in this context. Yeah? That's all it's really saying. K has to be an integer. Not it? Now, all it's really asking for is scientific notation, and it's actually a classic for IB. They really like to do this. Now, that being said, the other thing I can sort of point out is that part BI, whenever you have something with 2 parts, I and double I, see? Almost always, in my experience, part BI is heavily related to part B double I. And why do I mention this? It can be a very big hint to know what to do moving forward, see? In this case, it's very literal. It's like, yo, whatever you did in part BI, apply it now, see? But in some other context, maybe in some other exercise, when there is more than one part to it, maybe they're related, maybe they can help you identify how to move forward, okay? So that kind of hint is important to keep in mind because sometimes it can really save you. For example, here, see? Maybe you need to sketch the graph before finding the x-coordinate or to find it faster or whatever, see? So just keep it in mind, it doesn't always apply in this test. It doesn't really apply much at all. But in other tests, I've seen it be very, very useful. Okay, so any exercise that has parts to it, they're usually heavily related. It can be a big hint on how to move forward. See? So all you have to do in this part is leave our answer in part BI in scientific notation. So how the heck do you express this in scientific notation? So technically, and this is what I need you to understand initially, okay? If you take this number, the 278,000,000, and you divide it by, I don't know, 100, what just happened? You went from having 6 zeros to having 4. And that's because when you divide by 100, you got rid of, how many zeros does 100 have? It has 2. So, that's a way that you made the number sort of smaller. Now, take a moment and think about it. How can you also express 100? You can express 100 as 10 squared. Oh, that's interesting. That's very interesting. And so if you keep going like this, eventually, you can try to reach a number that is between 1 and 10. Now, which number is between 1 and 10 here? Is it 78? No. Is it 27? Neither. But you can identify, and this is huge, this is a big first step, 2.7. So technically, you can take 2.7, or actually, you can take 2.78, better said. You can take 2.78, multiply it a bunch of times, and end up with the same number. So let's see how that works. You can take 2.78, and if you multiply by 100, okay, you moved a little bit, but not enough. If you take 2.78 and multiply by, let's say, 1,000, well, now you're getting closer. And so eventually you're going to realize, how many zeros do I need to put? Well, how many times are you moving? You move once, twice, 3 times, 4 times, 5 times, 6, 7, 8. So if you take 2.78 and you multiply by 8 zeros, you end up with the same number. Now that doesn't look exactly pretty to put all those zeros, right? But I can express this as 10 to the power of all those zeros. And how many zeros was it? It was 8 zeros. There is your scientific notation. So all you really need to do is first identify your value of A, which in this case is 2.78, and then identify how many times you have to move the decimal place from here. And what we counted and found out is that you moved it 8 times. So that is how you identify that the answer is 2.78 times 10 to the power of 8. So all you really needed to do or review was how the scientific notation works. See, a lot of it has to do with identifying A correctly. Initially, I did the mistake of identifying 2.7, and that's not good enough, because if you use 2.7 here, what you actually end up with is something very similar to the answer, but without the 8. And you need the 8 in this case. You need it, because it's right there. So, I'm glad I made that mistake, because then we can review it together. For part B double I, that is my answer. We're all happy. We double checked here. There we go.